Alright, so this is for Chapter 13, the last two gas giants, the last two planets in our solar system, Uranus and Neptune. Chapter 14, just to let you know, will deal with Pluto and other objects in the solar system, like asteroid belt and the Kuiper belt and the Oort cloud. We'll talk about that later. Anyhow, there's a nice picture of Neptune. Neptune is the bluer of the two. It's actually a little bit larger than the planet Uranus. Uranus is more of a kind of a aqua or greenish color, as you'll see. All right, so these are some of the things we're going to talk about in Chapter 13, the discoveries, some physical properties, the atmospheric properties, which are they're very hard to see. I should mention that right now. They both have relatively strong magnetic fields. I mean, not as strong as Jupiter or Saturn, but they still have magnetic fields. We're not exactly sure what's causing those magnetic fields. They both have moon systems, and they both have very faint ring systems. So all of the gas giants have Jovian planets, also known as gas giants. Also, they all have ring systems. Of course, Saturn's is the most prominent and can be seen easily through a telescope, even a small pair of binoculars, as a matter of fact. All right, so William Herschel was the one who discovered the planet Uranus. He was an English astronomer, and this is the year that he did it in 1781. So we could tell that very, very early on that the planet Uranus had moons. There were 3 bright ones. The moon Miranda is probably the one that's the most interesting. Anyhow, I mean, they're all interesting, but we'll see that in just a little bit. So really, there was only one spacecraft so far that ever visited the two planets, Uranus and Neptune. So this is what Uranus looks like. You can see there's hardly any features at all in the upper atmosphere. There's little wisps of white clouds, but for the most part, it's kind of aqua color. Anyhow, the one spacecraft was called the Voyager 2. Voyager 1 visited visited Jupiter and Saturn, but then it was projected perpendicular to the plane of the solar system, and was basically headed out towards interstellar space. The Voyager 2 spacecraft encountered Jupiter and Saturn, but then went on. In 1986, it encountered Uranus, and in 1989, it encountered Neptune. All right, so there's a nice Voyager 2 image, and again, these are the best images that we have of these two planets. Even the Hubble Space Telescope can't get that kind of detail on these two planets. Although we can see the two planets, obviously, with the Hubble spacecraft. There's the Hubble Space Telescope, sorry. So Neptune was discovered in 1846. It was calculated before it was physically discovered that there would be an object in the outer part of the solar system, because the orbit of Uranus was odd. There was something going on that was causing Uranus's orbit to be a little odd. There was obviously some massive object, and which of course turned out to be Neptune out there in the outer part of the solar system. All right. Of course, Neptune has moons. I think you can only see 2 of them from the Earth, Nereid and Triton. Triton is the biggest moon in the outer part of the solar system. All right, and Triton turns out to be very, very interesting. We've actually seen geysers of nitrogen. Anyhow, we'll get to that shortly. All right, so there's a nice picture of Neptune. This feature right here was dubbed back in 1989 the Great Dark Spot. Comparing it to the Great Red Spot, of course, on Jupiter. This feature is actually gone now. We can aim the all right, so sorry, I got a phone call in the middle of that. I hope you didn't hear that. Anyhow, all right, so this is again, this is called the Great Dark Spot. We observed it for many years, and it's completely gone now. It's vanished. Basically the cloud structure has changed, and so this thing blends in with the upper atmosphere of Neptune. The compositions of these two planets are extremely similar to each other. They're almost the exact same size. They're made of the same material. I mean, there's slightly different amounts of ammonia and methane in these two, and that gives them the two different colors. But you can clearly see Uranus is more greenish colored and Neptune is more bluish colored. All right, there are some of the physical features. There's the mass of Uranus, about a little, 14.5 times the mass of the Earth. Neptune, a little bit more massive, 17 times more massive than the Earth. Uranus, like as far as the radius goes, it's actually just a little bit bigger than Neptune, but they're almost the same size. I mean, they're very close to being the same size. Notice the density so they're made of slightly different material. The density of Uranus is closer to that of liquid water. Liquid water would just be a 1 gram per cubic centimeter. This is in kilograms per cubic meter. Anyhow, the planet Neptune, of course, is a little bit more dense. All right, so here is a very interesting feature of the planet Uranus. It is actually tilted on its side. So it's tilted by about 90 degrees. So as it rotates about its axis, the axis is tilted about roughly 90 degrees to the plane of the solar system. And so, of course, as the planet rotates about its axis, that axis points in the same direction. So this causes extreme weather, extreme differences in weather, for example, in the northern where the northern pole is, it's basically in darkness, for half of its orbit. So, to look at the orbits here, let's take a quick look at this. The period of Uranus is almost 84 years. So basically 42 years. We'll go back to this picture. For 42 years, roughly, the poles are in darkness. All right, so that's a huge difference in the seasons. Let's see. The atmosphere is it's very cold out there in the in the outer part of the solar system, cold enough to freeze ammonia, and of course methane is what gives the different amounts of methane cause the different colors, the two different colors between the two planets. Of course, this is Uranus, the more greenish color. All right. We do see some cloud features, but they're very faint on the planet Uranus. Neptune has much easier cloud features to see. So there's of course the Great Dark Spot that is, as I mentioned before, is gone now. The bottom of these three pictures of at the bottom are in false color. That's just to emphasize the cloud structure. All right. Let's see. Oh, so the magnetic fields. Of course, Jupiter and Saturn have relatively strong magnetic fields. Jupiter has the strongest of all the planets. But notice the orientation of it is very close to the axis of rotation for both of these, Jupiter and Saturn. Whereas for Uranus and Neptune, compared with the axis of rotation, the magnetic fields are at huge angles to this, to where the axis of rotation is. And we actually don't understand that well. There's a few models to try to figure out what's going on in these two planets, but we still have many questions about how that happens. Again, the only spacecraft to ever encounter these was the Voyager 2 spacecraft. By the way, Voyager 2 and Voyager 1 are still in communication with the Earth. They have a nuclear power plant, well, it's a nuclear battery basically, but it should last, a good well into the like I've heard it should last at least to 2026. The batteries on these things, but once the batteries are gone, there's no more radio communication with those two spacecraft. All right, so here's the interior of the two planets. There are I'm sorry, they're showing Jupiter and Saturn, but over here on the right hand side is the lower half. Anyway, it shows Uranus and Neptune. Molecular hydrogen, and then surrounding more dense metallic hydrogen, and possibly even a rocky core at the center. All right, so here are some of the moons. Notice the moons of Uranus are named after Shakespearean characters. You might recognize that. So there's the size of the Earth's moon at the bottom. Oberon, Miranda, which is very interesting. There's Ariel. Actually, sorry, Nereid is a moon of Neptune. But these other ones, Titania and Umbria. Anyhow, those are some different photographs from the Voyager 2 spacecraft of those moons. All right, so here's the 5 major moons. Miranda, you can just see them. They're very close to the medium-sized moons of Saturn, but they're, as it says, they're less reflective. Umbriel is the darkest of them. All right. So there's Miranda. So here's Miranda. It's got some very strange surface features, and we're really not sure what caused these large grooves and the cracks in this moon of Uranus. So that's still a mystery. Neptune has roughly 13 moons, and of course we can see Triton and Nereid from the Earth. They just look like little specks of light moving around Neptune. All right, so here's so there were, as I mentioned earlier, there were geysers, nitrogen geysers observed coming from the moon Triton, which is the largest moon of Neptune. And of course, that was by the Voyager. you know it was the Voyager 2 spacecraft because thus far we don't have any other, and there's no plans to send anything out there. Maybe in your lifetimes, they'll go back there. This is some of the surface features of